Okay, in this presentation we are going to look at joint probability distributions of discrete random variables. So we have two discrete random variables here, x and y, and they have the following distribution. So we have x equals 0, x which can take the values 0, 1 and 2, okay, and also we have y which can take the values 0, 1 and 2 also. So far so good. Now what we have here is the probabilities of each possible outcome. So we have 9 possible outcomes, okay? And what we have here is the probability of each of those 9 probable outcomes. Possible outcomes, I should say. Something we should do later on is just check that do the total sum of all these probabilities add up to 1. It will, but something we should check, because if it doesn't, there's a mistake. Okay. Now, the first question is calculate the marginal distribution of x and y. Then calculate the expected value of x and then calculate the expected value of y. So it's a short enough question really just to get started with. There will be similar sort of questions later on that will be a bit more complex. So let's look at essentially the marginal distributions are the rows and row totals and column totals of the probabilities. Okay, you might notice I actually spotted a little mistake there myself. So essentially what we do is we calculate the sum of each row. So 2 over 10 plus 1 over 10 plus 2 over 10, that gives us 5 over 10. So that means overall x equals 0 5 out of 10 times, okay? 50% of the time. Then let's go for each of the following rows. X equals 1, 0 over 10, 2 over 10, 1 over 10, that gives us 3 over 10. And then x equals 2, 1 over 10, 0 over 10, 1 over 10, that is 2 over 10. Now, something that we could do here right now while we have the chance is just see what the total there is. That is 5 over 10 plus 3 over 10 plus 2 over 10. 10 out of 10, that is 1. Okay, so that's the marginal distribution of x, and I'll just sort of formally state it shortly. Now we're going to look at the column totals there. X equals 0, y equals 0, y equals 1, and y equals 2. What we do there is just tot up the totals there for each of the 3 columns. 3 over 10, 3 over 10, and 4 over 10. You can just do it very quickly there now. I think you get the idea. So we're going to use these values here to formally state the marginal distribution of x and y. So just a sort of statement like that, marginal distribution of x and y, x equals 0, x equals 1, x equals 2. And there we have y equals 0, y equals 1, y equals 2. So this is really a formal statement of the marginal distribution of y. Just actually when you're sort of putting down an answer like that, just don't do the row totals and column totals. That's fine as showing us your calculations, but you do need to put in a little statement there about what the marginal distribution of x and y is. And even then, just put a bit more work into it than I'm doing, just a bit more of a description and so on. So for example, you can just write in x and y here. So anyway, I'm just digressing there. So essentially that is part A done, calculate the marginal distribution of x and y. So it's a straightforward enough calculation. Now, quick one to finish with. What we'll do there is calculate the expected value of x. That is the sum of each of the x values times their probabilities. So 0 times 5 over 10 plus 1 times 3 over 10 plus 2 times 2 over 10. Okay, and that is based on this information here. Okay, so the value times the probability, multiply them out and add them all up. That works out to be 7 over 10. Okay, and likewise we do the same for y. The expected value of y is the sum of all the y values times the probability of those y values. 0 times 3 over 10 plus 1 times 3 over 10 plus 2 times 4 over 10, that works out to be 11 over 10. So the expected value of y is 1.1, which is to say 11 over 10. Okay, so I think that is it. Yeah, we'll leave it there. And yeah, we'll leave it there.